promise. Okay. All right. Rational exponents. Rational exponents basically mean fractions. Fractions for exponents. Okay? And fractions for exponents actually represent square root signs. It's just a different way to write it. So what I'm dealing with today, I'm going to start you out kind of slow here, because most of you, if I put this problem down, what would you tell me this is saying?
Square root of 16.
Right, the square root of 16. Okay? What does that actually mean?
8.
Oh,
Be careful.
a number times itself has to equal 16, right? So I'm looking for the answer to this would be a 4.
So it's just like 4 is the same.
That's where I'm headed with this. Okay. When you guys said the square root, you automatically made an assumption. Squared meaning is a power of 2. This is the square root symbol. This is the radical sign. And when you see no number in front of it, you assume it to be a power of 2. So you're looking for a problem, a number here, that times itself would give you the answer. So you needed 2 of them. So you would say the square root of 16 is 4, right? But not always will it be just a square root symbol. Occasionally and frequently during this lesson, you will see a number in front of the square root symbol. Well, if this said I need 2 of them, wonder how many you need here?
3.
3. So what number times itself 3 times?
2.
A 2. A 2 times a 2 times a 2. So the root here would be a 2. The cubed root of 8 is a 2 because 2 to the 3rd power is an 8. You kind of see how it all kind of makes a big circle. It just all goes around a big circle, right? So each of these, the symbol here is the square root. This is a cubed root. We would call this a 4th root. This is a 5th root. Each of these is telling you how many things I'm going to be multiplying times itself down here. All right? So that's the basics of the very beginning of this. Now, if we have a fraction for an exponent, so if I have like 18 to the 1/2 power, what I'm actually telling you here is I want a power of 1, but I want the squared root. So if I wanted to actually write this with one of these radical symbols, if I want a 2 for the root, I want just the plain square root symbol, right? And I want that answer only raised to the 1st power, so I would have an 18 all by itself under the square root symbol. So you can write a number that's been raised to a fraction as a square root problem, or a root radical problem. And that's kind of what these are starting out at in the beginning of the notes today. And we're going to become a lot more complicated, but the difficulty level doesn't get worse. It's the same procedure, just different numbers. So if we look at our notes, the main thing is to remember that the power is on the top and the root is on the bottom, and it's alphabetical. LMNOPQR, top to bottom, okay? So if I have the square root of 31, I'm looking for the root to be a square root, so there's a 2. And was there any power here? No, that's why I have a 1 for the numerator. So the power was a 1 and the root was a 2. The whole first half of your assignment is to switch your stuff from radical notation into rational exponent notation and back and forth, okay? It's going to get a little easier. It's a little confusing right in the beginning, and then all of a sudden it'll click, so hang in there, okay? Here is an example of 6 times a to the 1/2 power. This is what it would look like if I were to write it in radical form. Why is only the A under the radical symbol? There's a reason.
Because it's the only one that has the power.
Good, yes, because remember our exponents, they are powerful, but they're pretty lazy. They are only attached to what's directly in front of them. So only the A will be under the square root symbol. The 6 will be out in front. It's 6 times the square root of A. So look at D here. Notice how this is written as a radical. 3 times the square root of 5c. Notice the 5 and the c are underneath. Therefore, the 5 and the c both have to be affected by the exponent, and that's why you have to put them in the parentheses. If there's more than one, you need to put parentheses. No, we're doing the exact same thing as we did. Oh yeah, we're trading back and forth, yes. Right, we're going to trade back and forth, writing it both ways, changing it. So, look at this, try it. 3x to the 1/2. They want us, and look at what the directions say. Write this expression in radical form. Radical is the square root symbol. So I need you to write this using a square root of some type. What would you have?
3 square root x.
Perfect. Perfect. Perfect, because that 1/2 only affects the x, right? Okay. And what about this one?
7 square root m.
7 times the square root of m. We should make up then. Huh? No, it really isn't as hard as it looks. It really is not. I'm going to make one up here real quick. Let's see. How would you write that one as a radical with exponents?
4 3x. 4 in parentheses. 3x.
4, and then definitely parentheses, because all this stuff is under the square root symbol. So 3x is raised to the 1/2 power. It looks, yeah, it's very straightforward, but it looks complicated. And I just want to tell you, math is like that. A lot of it looks really scary, but once it's explained to you, it makes a little bit more sense. It's a lot less scary. So don't look at things and go, whoa, I can't do this. No, look at things and then maybe listen to the stuff or read a little bit further, and you'll find that you're smart. You can figure this out, okay?
Well, math is easy. It's just.
Well, not for everybody. Well, math is algebra, so not everybody finds it easy, though. All right. So now we're actually going to find the root, meaning I'm looking for the number that actually makes the mathematics here truthful. Okay, so if I have a 4 in front of my radical, I'm looking for the 4th root.
We just divide 625.
No. Hi. Okay. Thank you. All right. All right, so I'm looking for the 4th root. Now what that means is I need a number times itself 4 times that would create 625. And this is going to be a guess and check sort of lesson, all right? So I'm going to use a little bit of common sense. Yes, I know some of your calculators can do this, and I'm not going to show you how to do it in your calculator because I really don't want you to do it in your calculator. But I don't mind if you guess and check your way through your calculator, meaning I know that 625 is a big number, so I'm looking for a number to the caret 4 that would give me 625. Well, you're going to get there really quickly if you can guess and check. So let's pretend we don't know the answer is 5. What would be a good starting point possibly? What number do you think would go into 625? That's not 5. Let's just pretend. 2, okay. 2 caret 6. 2 caret 10. Oh, 2 caret 7. 2 caret 8. 2 caret 9. I'm obviously not going to get there because 2 caret 10 was way too big. So it isn't 2. But since 625 ends in a 5, you might have thought, oh, maybe 25. 25 caret 3. Ooh, I guess that's not going to work, huh? How about 25 caret 2? Oh, 25 caret 2 worked, but I needed 4 of them. I should have been doing caret 4. So 25 caret 4 would have been ridiculously huge. So 5 caret 4 gives you the 625. So 5 times 5 times 5 times 5. So 5 is the root that we were looking for. So this is called the root. So the 4th root of that number is the number 5. See if you can figure out the triad here that's got 216. And what root am I looking for here? A 3rd root. So what's that mean? I need a something times a something times a something. And they all have to be the same number. Well, see, it didn't take you any long at all, did it? Time at all. So 6 times a 6 times a 6. So the root, so the 3rd root is equal to the number 6. So it's really not that bad, is it? It's, like I said, it's a little bit of guess and check, but it really doesn't take very long to get the right answer. Okay. All right. So this is when they gave you the radical symbols, looking for a particular root. Now we're going to change it and give you a fraction for your exponent. You're still looking for that root, so you could change it, if you need to, into a radical. Okay? Since this is the power, and this is the root, I need the 3rd root of that number. Okay? So, guess and check, you find out that it's 7, and I need the 1st power. Well, what is 7 to the 1st power? A 7, so it doesn't change. So when you have your 1 as the numerator, you don't have to worry about anything. Yes, ma'am?
Will we ever have to play a higher number than
Oh, yeah.
1?
Oh, yeah. We're going to turn the page up. Don't be scared when we flip the notes over. You're so smart. You anticipated what was coming. Okay. What root do I need on the triad here? I need the 5th root. So I need the 5th root of 243. Have no clue. 7 caret 5. Ooh, that's too big. So I need it to be the 5th power. 6 caret 5. Ooh, 5 caret 5.
Would it be a decimal?
4 caret 5. Nope, it's going to be a whole number. It's 3.
Yeah.
3 caret. That's going to be my next one, too. Yay, 3 to the 5th power. So, 3 is the root. It's the 5th root. Because it tells me I need 5 of them. Okay? So, start to make a little sense? Yes, no, yes, no. A little shaking head. A little bit. Okay. Flip it over. Now we're going to go where I wanted to go. Yay. Okay. Sometimes they don't give us a 1 for our numerator, but we're so smart, we're going to fix them. Okay. So, remember the top number is the power. The bottom number is the root. I need the 4th root of 16. So there's the 4th root of 16. The number is 2. 2 times 2 times 2 times 2. Then I need that answer raised to the 3rd power. Well, that's easy. 2 to the 3rd power is 8. So the power is the numerator, the root is the denominator. So yeah, it's not bad.
What?
Okay. You could set up your radical. As we did before, the bottom number is your root, so I need the 4th root of 16. I calculate and figure out, aha, it's a 2. So the root, the 4th root is a 2. But this is saying I need it now raised to the third power. So 2 to the third power, the answer is 8. So you're finding the beginning answer, and then you're just taking it to whatever power that numerator is asking of you, okay? So what's the root on this second try it here?
3.
Right, so I need the cubed root of 27, and after I find that, what am I going to do with it? Raise it to the 5th power. So get this answer. So what is the cubed root of a 27? A 3. And now I'm raising it to the 5th power. 243 would be my actual final answer. No, once you get the hang of it, it really is not bad. Now, this bottom part is not bad either. It looks really big and hairy, but it's not. Don't be scared. It's going to be okay. I'll hold your hand. All right. Right here where it says solve each equation, you're putting a big star, and you're going to put make bases match. Because if you make your bases match, this becomes super simple. All right. When you're given an equation and they ask you to solve it, you're trying to look for a real answer, like x is equal to a number or y is equal to a number, right? So there should be a legitimate number for an answer here in the end. I have 4 to some power is equal to 1024. The fact that they give you a 4 here tells you that you should be able to go 4 caret something over here to make a 1024. This is your base. The 4 is the base. See if you can convert this number into 4 to some power. It is 4 to the 5th power. There's a powers property of equality, meaning when your bases are matching, you kind of wipe them out. Remember how we used to take the pants off our denominators in our fractions? We just wiped them all out when they all matched. Yeah, okay. Well, this is similar. This is similar. If your bases are matching, you're able to cancel them out and deal with only the exponent part that's left over. And in this case, there was nothing left to do. It was done. Y equals 5. So 4 to the 5th power is the same as 1024. But when you get to something like this, it's not quite so easy, but I'm going to walk you through it. I promise it's not nearly as complicated as it looks. All right, I'm going to cover it up so you can't see it. All right, so here's the deal. You've been given a 36 and a 216. You need to make bases that match. I don't think 36 is a base, but I could check it and see. 36 to some power, will that equal 216? Well, let's find out. 36 caret 2. Oh, good gosh. So just that's definitely not a base, because I can't get any smaller, can I? So I have to somehow change this 36 into something smaller. What? 6 to the second power. It has to be something I can square or cube or something. So 6 squared, so I'm going to say, okay, I'm going to rewrite 36 as 6 squared. That makes sense, right? Mm-hmm. Okay, so that's exactly what they're going to do here at some point. I'm going to ignore that side. So there they did it, 6 squared. Notice they left their exponents the same. The fact that I was able to change this one into a 6 tells me I probably can change the 216 into something to the 6 to some power as well. Okay, so now, guess and check. So 6 caret 4. Nope. 6 caret 3. Oops, how about not 6? I got 6. Aha! 6 caret 3 works. So this side was a 2, this side is a 3. Are you with me so far? Alright, now, I have an exponent here. This exponent times this exponent distributive property. Alright, so this is going to become a 2x plus a 4. So I now have 6 to the 2x plus 4 is the same as 6 to the 3. Remember that exponent property that if I can get my bases to match, I can wipe out the bottoms. Boom, boom. And now I just deal with what's left over. 2x plus 4 is equal to 3. Yeah, subtract the 4 from both sides. So 2x is equal to a negative 1. Divide by 2. So x is legitimately equal to a negative 1/2. So all that junk they did looks way more complicated than what we just did, doesn't it?
Yep.
But that's exactly what we did. Find bases that match, wipe them out, and deal with only the exponent part, okay? Alright. If your numbers don't have an exponent, like this 3 on the last example, give it an exponent so you don't forget. And then you can see we rewrote 27 as 3 to the 3rd power. We multiply our exponents together, so they become a 3x. I canceled out my bases here. That's why you don't see this. And then you solve the problem. Let's see if we can do the 2 triads. I think you'll be surprised how quick this goes. Okay. So since this is a 6 to the x power, I bet this is going to be 6 to the something. You got it to the 4th already? Okay. Now that I have bases that match, I cancel them out, and my final answer is 4. Yeah, done. Alright, let's try the next one. Obviously, I hope you see it's obvious, it appears that the base is going to be a what? A 2. It's a good choice. Let's find out if it happens. What is 2 to what power? What'd you figure out? 7? Okay, 2 to the 7th power. I now have bases that match. So I have x minus 1 is equal to 7. I add 1 to both sides, so x is equal to 8. See how these are not at all complicated? Get your base to match, wipe them out, and then just deal with the math that's left over. This homework goes really quickly, guys. I promise it does. So if you will open your book to page 410, I want you to look at number 54, if you would. Because there may be a situation there, I don't remember, or from last year or not, but I'm having a feeling. Okay? Look at number 54. Okay, this is number 54. Somebody real quick, and I don't know, see if 9 caret something, because I'm assuming the base could be 9, okay, since it's there. 9 caret something, can you get a 2187? Okay, since I can't get that to work, that means I may have to change this into a different base. A 3, could you rewrite it as 3 squared?
Yes.
Okay, so maybe 3 to the 2nd power, and then remember, when you bring it down your other exponent, you have to do your distributive property here. And I bet you can make it work after that with 3's, okay? So that's just a heads up on number 54. You're doing the evens, it's going to go quick, there's no story problems. And you got any questions, or seem okay? Seem okay? All right.